Hey, what's up everybody? This is Cameron Snow with Danomics.com. So in this video, I am going to be talking about how you can use some machine learning within Danomics to act as a QC assistant for your petrophysical interpretations. So when it comes to doing machine learning in petrophysics, there's a couple of ways that we've seen this done. Typically, it's people that are working with wireline data, so your well logs, or with core data, things like that. And they're trying to generate some predictions. So the type of predictions that I've most commonly seen are when they take wireline data and they use it to either predict missing curves or to supplement their log data set in some way, or trying to use it to predict reservoir properties. And at Danomics, we've published a couple of ERTEC papers along these lines. So when you are trying to predict some missing curves, what you may do is you take a handful of wells where you have a very complete log suite. Let's say you've got a full quad combo that has, gamma ray resistivity, neutron density, sonic, shear sonic, and you use it to try to predict logs that are often missing in other wells. So maybe you're trying to predict a missing sonic log or a missing shear sonic log in many cases. So you would build those models and you would predict those missing curves. In other cases, what you're trying to do is maybe you're trying to make a direct prediction of your reservoir properties. So in this case, you would take some petrophysical interpretations that have been made. You would then, uh, you know, train a model to take in the raw data and make a prediction of something like clay volume or TOC. And how people use these, is then you know a matter of choice. But a lot of times when I've seen people try to predict reservoir properties, they make that prediction and then they push that into a downstream model. Now, this can be dangerous because obviously, if your model is inaccurate, you're going to get spurious results. The other problem is it can often be difficult to interpret why the model is giving you certain results. So with that said, I don't necessarily like using the predicted values from the machine learning model to send to a downstream process. But what I do like to do is I like to use the results from that machine learning model to serve as a QC check on my interpretation. And that's what I'm going to show you today. So within Danomics, we have a lot of tools that allow you to utilize machine learning. And I'm going to show you a couple of those here now. So what I've done is I've gone through and for a small number of these wells, around 5 or 6 wells, I've made a full petrophysical interpretation. I've gone through and I've QC'd my input logs, done normalization, washout repair. I've interpreted by hand on a well by well, zone by zone basis, TOC, clay volume, porosity, and water saturation. And what I've done is I've then built up a blueprint and I've applied that blueprint to all the other wells within my field. Now, QCing this can be quite challenging sometimes. You start to pull up 70, 80 wells on a cross section or on a map, and sometimes it can just be hard to really focus in and distinguish what is just natural variation in the subsurface properties versus what's a problem, especially when you're only looking at a few percent difference on something like porosity, where 1 or 2% difference, it might not show up very well when you're looking at it, but it makes a big difference in your final results for like things like volumetric calculations. So what I've done is I've taken those interpretations, I've come over here and I've used some of Danomics tools to train a series of models to predict things like clay volume, TOC, porosity, and saturation. Once I've made those models, I then come over here to my prediction tools and I've made a prediction for clay volume, TOC, porosity, and saturation, applying the models that I had trained in this step. Now, once I've done that, I now have two interpretations that are in all of my wells. I have the interpretation that I've generated using my standard petrophysical workflow, and I've got the machine learning based interpretation. And what I've done is I've gone through and I've updated my templates so that now I can see, what is the difference between my machine learning based interpretation and my actual interpretation. And I've added shading here, where it's shading red when my actual is lower and green when my actual is higher. And what I would look for would be, big differences, large areas of shading in here. And I've done this for clay volume. I've done this for our total organic carbon interpretations. I've done this for our porosity interpretation, so we're looking at our total porosity. And I've done this for our water saturation interpretation. So done this for a broad range of properties. And now what I'm going to do is I'm going to use these templates that I've set up in cross sections to guide me to areas where I may have um, where I may have lower quality interpretations that I need to fix. So let's take a look at how I might do this. So let's say, for example, I go to a cross section and I want to look at my clay volume interpretation. And if I jump over here to the well that I was just on, I can see, all right, there's my kind of baseline. This is one of the wells that I've trained the model on. And as I scroll along, what I want to do is I want to look to see, is there anywhere where I get a big misfit? Okay, so here's an area where it looks like my interpretation is substantially off. So what I would do in this case is I would come to this well log, and I would look at this and I would say, oh, okay, actually what's happened here, it looks like I have a bad interpretation of my neutron density. So whoever was working on this project has it looks like I got some bad parameters. It looks like they set, a bad matrix point in here. So maybe we want to go update that a little bit. Also looks like the neutron density parameters could potentially be made a little bit better. So let's adjust our interpretation a little bit. Let's just try and get that dialed in a bit better. Okay, and now what we see is the difference is quite a bit less. And we continue with that type of interpretation. Now let's say we wanted to look at the next one. Let's say we wanted to look at something like a water saturation interpretation. So once again, we would come in here, we'd select our template for doing the QC, and we would come through and start evaluating where do we have significant misfits between our actual curve and our predicted curve. And let's come back over here to a well where we know that we've got a good baseline. That's our Ample-X well in this case, and we see that we've got a good fit there. Okay, let's continue across. Okay, are there any wells where we're seeing something that looks like it could be a concern? Okay, once again, we've got a couple of wells here that look like they have a pretty reasonable difference here. So now let's go to our water saturation interpretation, pull up our well log, and okay, it looks like we've we've probably overestimated our RW at surface there. This is something that we could go in and change, get better alignment on that interpretation, come back here to our cross section. Okay, let's come back over to where that well was. Okay, here's we had this one other well where it looked like we had a bit of misfit. Let's take a look at this one. Okay, it actually looks like in this case we need to go the other direction here with our RW. Looks like we were a bit too optimistic, and so we can update that interpretation and see how it changes. And that is how you can use machine learning generated results to help you QC your interpretation and really dial in your answer. So it's all about generating those curves, but then not taking those curves to the truth, but using those curves as a way to help you flag wells where you need to put a little extra TLC into your interpretation. And I think this is a bit of a unique twist on how you could expand this type of interpretation. And I actually think this is something where you could use it not only as a QC on your interpretation, but if you were to go a step up the chain and use it as a QC on your input curves. So maybe you could go in and say, all right, let's build a model to generate a synthetic density curve. Let's generate a model to generate a synthetic neutron curve, a synthetic PE curve, and use that to help you identify areas where you have bad input data, because this is assuming that we've already QC'd the input data. So you could go a step you know towards the baseline and maybe use that as a way to help you identify wells where your input data needs a little bit of TLC before you even get to the point of doing this interpretation. All right, so I hope this has given you some food for thought into maybe how you can use machine learning in a bit of a different way than just trying to generate synthetic data or predict results, but how you can use it as a way to serve as a QC on your workflows and on your interpretations. If you'd like to learn more about how you can do this yourself within Danomics, please feel free to hit me up at sales@danomics.com, and we can jump on a call and I can show you how you can do this yourself. All right, thank you everyone, and happy interpreting.